Hey y'all, it's me, Miss B. Today we are talking about matrices. This is a topic that is frequently on the ACT, so that is why we are doing Chapter 8 after Chapter 2. Okay, so first let's define what a matrix is. A matrix is a rectangular array of numbers for which operations are defined. So the operations that we are going to deal with mostly are multiplication and addition. All right, the order or dimension of a matrix is determined by the number of rows and by the number of columns. So in the note that in a square matrix, the rows and the columns are equal. Okay, so when we are talking about numbering, so we might have like several numbers in a matrix. We could have infinitely many. The first subscript is our row. So a row is across, so we have a row. So this is going to be A1, and then our column is our second number. So this is 1, 2. So then this is still row 1. Oh wait, no, I didn't do that right. This is column 1. Then our next one, this is still row 1, but it's column 2. This is row 1, but column 3. Then moving down, this is row 2, but column 1. Row 2, column 2, row 2, column 3. It keeps going. This is row 3, column 1, keeps going. Okay, so it keeps going forever and ever and ever in every direction. So we indicate our row as n, so this is down here A1m. This is AN1. So then this is oh wait, no. Did I do that right? This is N, this is N. So, I messed it up. Okay, so then if this is column N all the way down here, this is A1N, and this is AM1. So then down here, this is AMN. So M is the row and N is the column. That is less important. Okay, so then the name of it is MN. All right, so we're going to identify to the right these values. So again, it goes row, then column. So we are looking in the second row in the third column. So second row, third column. So 0 is the value of this one right here. For this next one, we're looking in row 3, column 2. So -2 is that value. All right, and then for this next one, we don't have a fourth row and we don't have a fourth column, so this is non-applicable. Okay, this is a 4 by 3 matrix. All right, so let's go ahead and identify the order of the matrices below. So This one here, we've got 1 row and 3 columns, so it's a 1 by 3. And then this one has 2 rows and 1 column, so it's a 2 by 1. Go ahead and do this next one on your own. You should have said that it was a 4 by 2 matrix. Okay, so we have these things called elementary row operations, and I'm going to go through what they are. Okay, so there's this thing called a row exchange. We will not be doing this. That's for college math mostly. We have scalar multiplication, which is you are multiplying by a constant. And then the third one is matrix addition, where each number is added with a corresponding index. Okay, so here you'll notice that we have x and y right here, so our matrices are equal. So the 6 and the 4 are the same, and the 1 and the -2. So then x is going to be equal to 1, and y is going to be equal to -2. Just matching those up. I want you to go ahead and find x, y, and z on your own. So for this, you should have said that 2x is equal to 4 and solved, so x is equal to 2. You should have said y minus 5 is equal to 8 and solved, so y is equal to 13. And then for z, you should have said 2z is equal to 12, so then z is equal to 6. All right, hopping down here, we want to go through these operations. So this is going to be a bit of multiplication and addition. We're going to do multiplication first and then the addition, just like PEMDAS. So we want to follow PEMDAS. Okay, so I don't have a ton of space, so I have to zoom in. Sorry, those of you that are doing it at home on paper. So we're going to take this 2, and it's going to go to every single thing in here. That's kind of looking crazy, so I'm gonna erase that. But basically you're doing, I'll go ahead and write it out. 2 times -1, 2 times 4, 2 times 6, 2 times 0, 2 times 2, and 2 times 5. And then for this one, I like to do plus and then multiply by -3 all the way through. So I'm going to have -3 times -5, -3 times 3, -3 times 4, -3 times 1, -3 times -2, and -3 times 7. Okay, so when I multiply by -3, this becomes addition, which is much easier to deal with. So then, dropping down here, we will multiply these out. So I have -2, 12, 0, 8, 4, 10, plus the matrix 15, -9, -12, -3, 6, and -21. So what we did up to this point, this is matrix, or I'm sorry, scalar multiplication is technically what we call it. Scalar multiplication. All right, so now we're going to do scalar addition right here. So we are adding corresponding values. So let's make this a little smaller. So we're adding this together with this, and so on and so forth. So each of those are getting added with their corresponding value. So A1's getting A11 is getting added with A11, and so on and so forth. So 2, I'm going to go ahead and write this out so we have it. So negative 2 plus 15 12 plus negative 9, 0 plus negative 12, 8 plus negative 3, 4 plus 6, and 10 plus negative 21. Don't be afraid to leave yourself room so you don't accidentally combine things that aren't supposed to go together. And then we simplify, so we get 13, 3, negative 12, 5, 10, and negative 11. If you want to combine steps, you can, but don't feel like you have to. So this was scalar, or not scalar, this was matrix addition. Okay. Go ahead and do this next one on your own. So what you should have done was multiplied that through. So you should have had the matrix 4, 8, 12, 16 added with 5, 6, 7, 8. We add straight across, we get 9, 14, 19, and 24. And so this is our final matrix. All right, this next one over here, go ahead and do this one on your own. You should have said it was no solution. We can't add two matrices that don't have the same dimensions. Or I shouldn't say no solution, but more can't simplify. Okay. So when we are multiplying matrices, the number of columns in the first matrix has to match the number of rows in the second. So looking here at this first problem, this is a 2 by 3 matrix and this is a 3 by 2 matrix. Because this and this match, we're able to multiply them together. So let's go ahead and write this out. I'm going to change my pen color here. Okay, so we are going to multiply the first row by the first column first. And that number will go here. So it's going to be, I'll just put a little pink here. Okay, so first row by first column first. So we're going to do, and then we add those values together. So this will be, I'm going to make a big old matrix here. So I have 0 times 1 plus 0 times negative 1 plus 2 times 7. All right, and that is my pink. Next up, I need to multiply my first row by my second column. That answer is going to go right here. And I'm going to add all those values together. So I have 0 times 5 negative 1 times negative 1, and then 7 times 3. And that is going to be our green. Then I have to multiply my second row by my first column, and that answer is going to go right here. So that's going to go. Okay, so we have 8 times 1, 9 times 0, and -2 times 2. We add all those together. Then finally, I'm going to do my second row times my second column, and that's going to go right here. So I'm going to have 8 times 5 plus 9 times -1 plus -2 times 3. I'm going to put our final answer in here, so I'm just going to do some math off to the side here. So 0 times 1 is 0. 0 times -1 is also 0, and then 2 times 7 is 14. 0 times 5, we're on this one here, 0 times 5 is 0. -1 times 1 is 1, and then 7 times 3 is 21. Next we have 8 times 1 is 8, 9 times 0 is 0, -2 times 2 is -4. Then we have, lastly, 8 times 5 is 40. 9 times -1 is -9. Then -2 times 3 is -6. So 0 plus 14 is 14. 0 plus 1 plus 21 is 22. 8 plus 0 minus 4 is 4. And then 40 minus 9 is 31. Minus 6 is 25. Okay, so 14, this matrix right here is our final answer. We can get rid of our color coding here. Okay. You'll notice that we have a 2 and a 2 here, and we ended with a 2 by 2 matrix. That is not a chance. That is very much a intentional thing there. Okay, so this next one here, I've got 1 row by 3 columns and 3 columns 3 rows by 1 column. So I should end up with a 1 by 1 matrix in the end. Let's go ahead and do our math here. So I'm going to do 1 times 5 is 5, plus 4 times 3 is 12, and then 6 times 1 is 6. Add all those together, you get 23 as your matrix, which is 1 by 1. Okay, and then lastly, this last one here, we have a 3 by 3 and a 2 by 2. These numbers do not match, so cannot multiply. All right. So I know that multiplying was a lot of steps. Don't worry, we're going to do a lot of examples in class. All right. So then for this next one here, when we're solving a matrix equation, it's exactly what you think, but this is what I like to do. To set it up, I'm just going to rewrite this matrix. Make sure you don't copy it down wrong. I'm going to label X as 3 different things. So I've got A, B, C, and D. And that's all equal to the same matrix, 4, 3, 6, 0. So then I can create an equation for each individual variable. That way it's easier to find what X is. So 3 plus A is equal to 4. Just running across here. So 3 plus A is equal to 4. Then we have 8 plus B is equal to 3. 1 plus C is equal to 6. And -4 plus D is equal to 0. And then we solve each of those. So go ahead and find A, B, C, and D on your own. Should have got 1, -5, 5, and 4. So then big X is equal to 1, -5, 5, 4. All right, that's it for today, folks.